Hello, everyone. This is Mr. Bryce from Susquehanna Valley High School here in Conco, New York. Just reminding you, by being yourself, you put something wonderful in the world that was not there before. Now let's go on to Unit 3, Lesson 4. Linear modeling. So we're going to model a line. Common Core Algebra 2, non-Regents version. If you don't understand what I'm saying, just scan that QR code and you can listen to the genius that wrote these lesson plans. In Algebra 1, we use linear functions to model a process at a constant rate of change, a constant slope. Y equals 3x plus 7 has a slope of 3 with respect to the other, or constant slope again. In this lesson, we will review many of the facets of this type of modeling. So Tom was driving away from New York City at a constant speed of 58 miles per hour. He started 45 miles away. Interesting. Write a linear function that gives Tom's distance d from New York City as a function of the number of hours h he has been driving. Careful. So the first thing that I realized is that he is driving away from New York City, and we're writing a linear function that gives a distance from away from New York City, okay, as h he's been driving. So let me see. He was driving away from New York City at a constant speed of 58 miles an hour. 58 is the slope. Okay. So now 58 miles per hour is the slope, and it says that we have to use function number hours h. So we have to use 58h. He already was 45 miles away. And that's going to be the distance. Distance equals 58h plus 45. Hopefully he's driving away. 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 Good. If D is destination, Tom's, it is Tom, right? Is 270 miles away from New York City, algebraically determine the nearest tenth of an hour, how long it takes for Tom to reach his destination. 270 is the total distance, equals 58h plus 45. We know how to do this. We subtract 45 from both sides. Why are we subtracting? Because they're on opposite sides of the equal sign. Opposite sides do the opposite operation. 225 equals 58h. When I divide by 58, I get 3.87. H is 3.9. I almost wrote 3.87 there. Nearest tenth of an hour, how long will it take? It says hours in the question, so I don't have to put hours there. H stands for hours. Done. Stick a fork in it. It's clear from the context what both slope and the y-intercept of this linear model are. The slope, 58 miles an hour. The y-intercept, is 45. However, if we're just given something like this, where Edlin is trying to model her cell phone plan, she knows that it has a fixed cost per month along with a 15-cent charge per call that she makes. Last month's bill, she was charged $12.80 for making 52 calls. Create a linear model in the point slope. Why am I going to use point slope form? I mean, that's a strong hint. Use point slope. Why? Because we know what the rate of change is. Remember, point slope, y minus y1 equals slope x minus x1. We know what the slope is. It's 15 cents. Do we know what the x value is? Is the x value $12.80 or 52 calls? Which one's dependent? Which one's independent? Well, gee, the 1280 is dependent, and the 52 cents is independent. So the 52 calls, it's right there. Even though a lot of you might think that, gee, the number of calls I make depends on how much money I have. That's a smart budgeter. But that's not from the perspective of the telephone company. And now it says use C. Edlin must pay P minus 1280 equals 0.15 C minus 52. That was kind of dangerous starting off with x's and then rewriting the equation in terms of p and c. But we made it. How much is Edlin's fixed cost? In other words, how much would she have to pay for making 0 phone calls? In other words, what's the y-intercept, buddy? Why don't we just distribute and combine like terms and solve for p? P minus 1280 equals. Why am I putting the 0 in front of there? Because someone lost some points on the test because you couldn't see the decimal point. Then I add 7. Let me see. I'm going to solve for P. I'm going to add 1280. Always keep in mind what you're doing. Really? 1280? That's so nice of them. $5 is the answer. Let's go on to the next page. Many times when linear models have been constructed, we're only asked to work with these models. The models in the real world can be very messy. It's often convenient to use our graphing calculators to plot and investigate their behavior. Okay, a factory produces widgets in a generic object, no particular use. Hopefully it's used for something. The cost C in dollars produces W widgets is given by that equation. Each widget sells for 26 cents. Okay. Each widget sells for 26 cents. So there's a cost differential. It sells for 26 cents, but the cost is 18 cents per widget. Okay, at least it's a positive cost differential, so you will have a chance to make a profit. Use your graphing calculator to sketch and label each of these linear functions for the interval 0 to 500. Be sure to label your y-axis with a scale. Hopefully the volume is on and you're listening to me. The word of the day is calculator. Don't tell anyone. The word of the day is calculator, because we're going to have to use a calculator together to do this. So when you walk in tomorrow, we're going to complete this problem. Don't tell anyone what the word of the day is, but you're going to write it on your paper as we're doing this problem. In fact, you can write it on your paper right now. The word of the day is calculator. And I'll see you later, ladies and gentlemen. Bye.